Alright, are you ready for the joke of the day? I got my sister a refrigerator for her birthday. I'm so excited to see her face light up when she opens it. Today we're going to be looking at rational operations and working through a lesson on Delta Math that goes through each type. So my recommendation would be for you to have this video and the Delta Math assignment open up in separate tabs and to go ahead and try the Delta Math problems. I'm going to go through each type that we have in the Delta Math. So going ahead and trying the problems in Delta Math, and then whenever you get to one that is not making sense or you're struggling with, you feel like you need more direction, you can come to the video and maybe skip over some types and get to the one that you're struggling with. If you need to watch the whole video, then that's why I made the whole video, so you might need to watch the whole thing. Okay, so I am going to be going straight from Delta Math, just using the same problems that it could give you, because it's going to give random problems and work out whatever it gives me. So the first category is simplifying, which we've already talked about, but there are different types of questions that can come with simplifying. So this is the first example that Delta Math gave me that we are simplifying. It is a little bit different than some of the problems that we see because a lot of times they're trinomials that we can factor both and cancel that way. But that is what we're looking to do no matter what. So I'm looking to factor whatever I can out. In these situations, neither of them are trinomials. So I'm looking at my x squared minus 8x and seeing that they have an x in common that I can factor out. We always want to make sure when we factor that if I multiplied this back through, I would get what I started with. In the denominator, I can factor out an x and an x squared actually. I could go a higher power, but because the numerator only could factor out an x, I really only want to factor out an x here too because I can't go further than that anyway. So an x squared plus 4x is left. And then because I have x's in the numerator and the denominator, I can divide to be 1 so that I'm left with this x minus 8, x squared plus 4x. And definitely, if we had factored out an x squared in the denominator, or at this point, if you wanted to factor out an x, you can, but it's no more or less simplified because they're both, the same. They equal the same thing, they're equivalent, just this one would have the x factored out and that one wouldn't. For the second type of simplifying, this is more what we're used to where they're both trinomials that we can factor. So in this case, we would be looking for two numbers that multiply to be 40 and add to be a negative 14. So we've got an x minus 10, x minus 4. And at this point, we've actually done a lot of this with our chart. We've got an x minus 4, x minus 2. Just making sure I am not allowed to cancel those x squareds or these x's, that I need to have all multiplication to be able to cancel. Right now, all of this is attached. It's one thing. Unless you have exactly this in the denominator, you can't cancel it. But now that we have multiplication, we can cancel our x minus 4 and x minus 4. And we are left with this x, I don't know why I wrote 10, x minus 10 over x minus 2. So that is the gist when it comes to simplifying. Then we have multiplication and division. The first types are going to be where we don't have as complex expressions. So notice here we don't have to really factor anything. But whenever you're multiplying, we are multiplying the numerators, multiplying denominators, so make sure you don't cross multiply. That's something else. That is for when we have two fractions equal to each other. In this case, we're multiplying numerators, multiplying denominators, but also if I have anything that cross cancels, so in this case my x squared and x squared here, I can cancel those because one will end up in the numerator and one in the denominator. So let's go ahead and multiply and just see. If we did multiply these, we would have our 5x squared in the numerator, and then 3 times 2x squared is 6x squared. So we can see we end up with our 5x squared in the denominator, or 6x squared in the, in the numerator, 6x squared in the denominator. And so those x squareds ended up one in the top, one in the bottom. It's all multiplication because we were multiplying. And so I could cancel my x squareds here, or I could have canceled them beforehand here and then multiplied across and gotten 5 over 6. But either way, we end up with 5/6 for the first one. If we are dividing, it's just slightly different. So the next example they gave me is 6x over 5 divided by 9 over 5x squared. I feel like the numbers are really similar. We got a 9 now, but anywho. The only difference with division, we know this from dividing just regular old fractions without x's in them, that whenever I'm dividing fractions, I am multiplying by the reciprocal. So this is going to be equal to multiplying by 5x squared over 9. And we want to do that at the very beginning because that is our way of dividing, is multiplying by the reciprocal. But then we can see here we've got our 5's that can cross cancel. They will end up being a 5 over 5, which is 1. And then we could go ahead and cancel here, or reduce really, with our 6 and 9. They're both divisible by 3, so I could divide 6 by 3 and 9 by 3. And now I'm ready to go ahead and multiply across, where I've got my 2x times x squared is a 2x cubed, and then over 3. If you get at the end here and you still see something that you can simplify, or your coefficients, the 2 and the 3, if that's a fraction that can be simplified, then we want to keep going until it is completely simplified. The second type of multiplication and division is just a little bit more complicated, where we have our expressions can be factored. So for this type of multiplying, whenever we see things can be factored, I do want to just start by factoring everything. So instead of starting by actually multiplying, we're going to start by factoring everything that we can factor, because it's going to be much easier to cross cancel things before I multiply than to, like, we don't want to distribute this 2x in. That makes it a lot more complicated. So we're going to start by factoring this x squared minus 3x minus 54. So I've got an x minus 9, x plus 6. We can factor the denominator as well. We've got an x minus 9. Already seeing some things that can cancel. With monomials, sometimes we can see that we can cancel with something else. So if we had like a 2x squared, we might factor out an x so that later we could see really easily to cancel with that x, but it's not necessary. So I'm just going to leave that as a 2x. And then for our x squared plus 8x plus 12, we've got an x plus 6, x plus 2. Okay, so using all of our factoring skills, and now I can look at canceling within a rational, so my x minus 9 over x minus 9, but then also cross-canceling because x plus 6 will end up being divided by x plus 6, and then we also have an x divided by x. So in the end, if I had anything left over here, I would be multiplying the numerators and multiplying the denominators, but I really just have 1. So in this part, I have a 2 over x plus 2 left. Just realized that I haven't been circling any of my answers. I'll circle that one. So let's do one more division example where it's a little bit more complicated. Remember, your first step in dividing is always multiplying by the reciprocal. If you see something else that can cancel, though, it doesn't hurt to cancel at any time. So like this x over x is going to cancel no matter what I'm doing over here. So we could go ahead and cancel that. And then we are looking to factor anything that can be factored. So we've got our x minus 9, x plus 9 in the denominator. And the numerator, let's see, a 9 and 2. Okay, so looking for things that can cancel, we've got our x plus 9s divided by x plus 9. And then we are multiplying numerators and denominators, so I've got a 3, x plus 2, and then a 2x minus 9. And again, I could distribute that 3 through, I could distribute the 2 through, but this is just as simplified as a 3x plus 6 over 2x minus 18. And I believe Delta Math will accept either of those. If it doesn't, then let me know and I can give you the point back for it because I can see your answer. But I believe it accepts both of those as an answer. I already switched off of it, or I would try it to see if it would tell me that's the answer. Next we have adding and subtracting fractions. So the first type, again, it's going to start a little more simple where we don't have things that need to be factored. But remember, whenever I'm adding or subtracting fractions, that I need a common denominator. So looking at my denominators, we can see for this first example that they have an x squared in common, but this first fraction needs a y squared as well. So that means that to have a y squared in the denominator, I am multiplying this by a y squared over y squared. I am always allowed to multiply something by 1, an expression by 1, and it doesn't change what it means. I'm not allowed to just multiply the denominator by y squared. Now I've changed everything. So we've got a y cubed now in the numerator, our x squared, y squared, and then our x squared, y squared here. Keep wanting to put plus. And now we can go ahead and add, once I have a common denominator, I'm talking about the same pieces, the same size of slice. Like if you have a 1/4 plus 3/4, you're talking about the same amount of fourths. You're adding them together. Anyway, so I can add my numerators, so my y cubed plus 1, and then they're over the same denominator. Sometimes we're adding or subtracting something where the denominators don't have anything in common, and in that case I will need to multiply the first fraction by the second denominator, so x cubed over x cubed, and the second fraction by the first denominator, which that always works. If I'm not sure what the common denominator is, I can always multiply like that, the first one by that denominator over itself, the second one by the first denominator over itself. It just means if it wasn't the least common denominator that you'll have more simplifying at the end, but that's okay. It will always work as far as getting you a common denominator. So we've got this x cubed over x cubed y, and then a y over x cubed y. We have a common denominator, so now we can add them together. We've got an x cubed plus y over x cubed y. Something that students are tempted to do here is once you get your common denominator and now you see this like x cubed over x cubed, you want to cancel it. Well, the reason that it's there is because you multiplied by that. So fight that temptation. You're getting a common denominator for a reason. Once you get the common denominator, go ahead and add. And now those things do not cancel because x cubed plus y is one thing. I cannot cancel it with either of those in the denominator. So the way that adding or subtracting our fractions could be more complicated is if it requires us to factor at the beginning to know what the common denominator is. So if we see trinomials, or here we've got this x squared minus 36 that can be factored, we will start by doing that. So I'm going to start by factoring my x squared minus 36 into x minus 6, x plus 6. And if we see that at the beginning, this was one that was not too bad to jump right into getting a common denominator. But since this has an x minus 6 and x plus 6, but this only has an x minus 6, that means that my second fraction is going to need an x minus 6. So I've got to multiply it by x minus 6 over x minus 6. And then I am going to have this common denominator of x minus 6, x plus 6. In the numerator, I have to distribute, so I'll have my 7x plus 1 still, didn't do anything to that. But over here, I have a plus 3x squared minus 18x, which we haven't had a subtraction one yet. I'll make the next one subtraction. But if this was subtraction, I would have to make sure to distribute a negative 3x to both so that I'm subtracting both of them. Okay. And then my last step is just combining my like terms. So I've got, start with my 3x squared, and then for my x's, I have a negative 11x, and then plus 1. In my denominator, it really doesn't matter whether I leave it in factored form or not. You can multiply it back through or put it back in your x squared minus 36 if you wanted to. In my numerator, I do want to check to make sure that I can't factor and cancel again. That doesn't happen very often, but it could. A lot of times this will end up not being factorable in the end, and I would have to have factors of 3 that add to be negative 11, so it is not factorable. Okay, last adding and subtracting, and with a subtraction one, because we do need an example there. Still needing a common denominator. The only part that's going to be different is that I am subtracting instead of adding. And I can notice right off the bat that I can factor this x squared minus 14x plus 49 into an x minus 7. So actually an x minus 7 squared, we could see it that way. That means that our second fraction is going to be missing an x minus 7. It needs 2 of them. So I'll have, I'm just going to write this as an x minus 7 squared. I feel like I like that better. In the numerator over here, like I was saying earlier, since I'm subtracting, now you could leave a negative sign and go ahead and multiply here, but leave the negative sign, or you could go ahead and distribute the negative sign as you go, which is what I'm going to do. So I'm going to treat this like a negative 2x. So I've got a negative 2x squared, and then a positive 14x. So either way, if you wanted to leave the negative there, and then have your 2x squared minus 14x, but then you'd have the negative in parentheses so that you would distribute that negative in. And really at this point we're done. We don't have anything to combine. If you wanted to put it in descending order you could, but I believe Delta Math is fine with any of those, and so am I. I am going to rewrite it for myself though, because it does make me happier. The last type that you'll have on your Delta Math is complex fractions, and that just means that you have a fraction in the numerator and a fraction in the denominator. So basically it's division, but a lot of times there will be other operations happening as well. So it's really a combination of any rational operation happening all at once. This is a type of problem that happens every once in a while in calculus, and to be honest, students a lot of times struggle. They'll do the calculus fine, and then they struggle with simplifying something like this. So very important. The first thing that we want to do is combine. In this case, we're adding the fractions in the top and the fractions in the bottom, so that I am just talking about a fraction divided by a fraction, because then at that point I can multiply by the reciprocal, no big deal. So in the top, in the numerator of the numerator, anyway, I am going to need a common denominator of x squared, so that means my first fraction is missing an x over x. So in the top I'll have this x plus 1 whenever I add them over x squared. In the the denominator, and I like to make that middle bar just like larger than a regular fraction bar so that it's a little bit easier to look at. But in the denominator of the denominator, we're getting a common denominator as well. And so let's see, they have a 3 in common, but this one's needing an x. And so then to be a 9x over here, this one would need a 3. So that would give me a common denominator of 9x. Again, if it's not the least common denominator, it's okay. We'll just have more simplifying at the end. So I wouldn't worry too much about that. As long as your denominators are the same, we're ready to rock. Okay, so in the first one, I've got an x and then plus 3 over my common denominator of 9x. Okay. So once we've got that, we are ready to look at x plus 1 over x squared being, sorry, I was going to write divided. I'll just write giant multiplication symbol, multiplying by the reciprocal of 9x over x plus 3. If at this point, if we could factor anything or cancel anything, we can. We don't have much here, but I do have an x over here and then an x squared, so I can cancel one of those. And then I'll multiply numerators and denominators. So I've got my 9x plus 1 and my x plus 3. And I checked on this one. They are good with you typing in that factored form. If you did distribute it through, that is fine as well. All right, let's try one more of these. Complex fractions or fractions within fractions. So again, starting by combining what's in the numerator, combining what's in the denominator so that I can divide the two fractions. So in my numerator, I'm needing a common denominator of x. So I can multiply the second one by x over x. In the denominator, I'm needing this common denominator of 3. So multiplying by 3 over 3. then I'm ready to multiply by the reciprocal. Oh, why did I write it as a mega fraction again? No! Just kidding. Our 9 minus x squared over x times 3 over x squared plus 3x. Yeah, helps me to say it out loud. If I have anything that I can cancel, I can from here. Now it looks like I've got some factoring that I could do. This guy looks almost like what we normally have when we are factoring something like that, but typically it's an x squared minus 9. So a little trick here that if I want this to look more normal, what I'm used to factoring, I can factor out a negative, and now I have an x squared and a negative 9. That'll help me there. I'm multiplying by 3, and I can factor an x out here. Okay, so there is going to be something that I can factor and cancel here. My x squared minus 9 is an x minus 3, x plus 3 over x. So we can see how these skills build on each other, the multiplying, dividing, but then also being able to simplify. And now our complex fractions. So our x plus 3's do cancel, and that's it. Make sure if you factor out a negative like this that we don't leave it. We want to keep that in our problem. So we've got in the numerator a negative 3, x minus 3, and then in the denominator an x squared. Again, we could multiply that negative 3, distribute it, but we do not have to. Okay, so my recommendation would be, so now you've got at least an example of each type. If you're still struggling, go ahead and try the delta math, and it will at least tell you how it is supposed to be worked, and go off of that. Talk to the people in your group if you're still having trouble. Have a good day.